Hello everyone, we are going to look at memory management by Aili Ruth Francisca. So to introduce, we are saying different programs and data execute in memory at one time. So programs and the data at one moment, of course, they will execute after going through various processes. So the operating system keeps tracks of which part of memory are currently being used by whom, which processes are to be loaded into memory, all that is operating system. So as a definition, we are saying memory management is a technique of controlling and managing the functionality of the RAM, how this RAM is going to manage, how it is going to perform its activities. That is the memory management we are talking about. So there is a brief diagram that shows the operating system and what it is helping in doing in the computer system. Then down we have the hardware. Then all that is on our left from where the operating system is, like the operating system is the one that is helping all these activities to take place, where memory management is also. Importance of memory management: it helps to keep track of the status of each memory location, like which processes are to be allocated, is the space free in memory. That is the work of the memory management. Then it also enables computer system to run programs that require more main memory. There are some programs that require more memory than the one which is there. So it is this memory management that helps these programs to run. Then it also addresses the system's primary memory by avoiding abstractions such as the programs running on the system. It is the job of the main memory to protect the memory allocated to all processes from being corrupted. Some processes might corrupt others, so it is the main memory that helps to protect the memories that are to be allocated from being corrupted by other processes. Then we also have enable sharing of memory spaces among processes. How this memory space is going to be shared amongst all these processes is the work of the memory management. Then we look at logical address space. Logical address space encompasses the range of addresses that a CPU can generate. How is this process going to identify its memory? All that is logical address space. Like when a computer has 4 GB of RAM, the logical address space spans from 0 to 4 billion, but this space is not entirely occupied by physical memory. So for physical address space, this is the actual physical location in the memory hardware where data is stored. We are giving an example of the RAM modules. So RAM modules, on the RAM chip, there is a printed circuit. It is like a printed circuit board on the RAM chip. So on which memory integrated circuits are mounted. So under it there are kind of cells. Like I said, memory printed integrated circuits, they are like circuits under it. So that is what we call the RAM modules. So it consists of 4 billion cells, and each of those cells correspond to each of the, like each address corresponds to each of those individual cells. So in the interaction of the logical and physical address space, one thing to note is the memory management unit. This acts as an intermediary between these two, transferring primary and secondary from physical, like it has been written, to enables programs to operate in a seemingly large logical address space. I hope we have got it right. Then we have static and dynamic loading. Static loading is where a program will load all its necessary components into main memory before it executes. So before this program goes under execution, it will load all its components into the main memory. As dynamic loading is where this program will load all its components into the main memory only when it is requested during execution. Then we have memory allocation. This is the process allocation, like how it is going to be portioned. It's a process of reserving a portion of the computer's memory for a specific program or application. To allocate, how is this portion going to be reserved for a program? Then we have contiguous memory. Contiguous is something like shareable, something like I can say shareable, sharing a common border, touching just like that. So we are saying a memory management technique is a memory management technique that involves allocating a process to the entire contiguous block in the main memory. it requires to execute. Like I said, contiguous is like shareable. Then we have fragmentation. This is where when processes moved to and from the main memory, the available free space in primary memory is broken down into pieces. So that available space in main memory will be fragmented, broken down into pieces. That is what we are meaning by fragmentation. Then the types of fragmentation, we have internal and external. For external, it exists when there is enough total memory space to satisfy a request, but the available spaces are not contiguous. The space is there, but the available, it exists when there is enough total space, memory space. The space is there to satisfy a request, but the available spaces are not shareable. The space is there, but it can't be shareable. That is what we are meaning by external fragmentation. Then internal fragmentation occurs when the memory block assigned to the process is larger than the amount of memory required. So for internal, the memory space, the memory block assigned to a process is larger than the amount that is required by that specific process. Then we have paging. We are saying paging is a technique of memory management in which the address space is broken down into blocks. Paging, these blocks are the ones we are calling pages. So we are saying the process address space is a set of logical addresses that every process refers to in its code. When a process tries to access a page that is not in RAM, the operating system brings in the page from the virtual memory. So from the virtual memory, it can be the hard disk drive. So when a process tries to access a page that is not in RAM, what the operating system will do, it will get a page from the virtual memory, I can say from the hard disk drive, and then bring it to the RAM. This is a simple diagram of what I was explaining. The RAM, which is the memory, main memory, it is divided into those parts 1, 2, up to 6. Those are the ones like the partitions, and we are calling them frames. In the main memory, we are calling them frames, the physical memory, but in the virtual memory, we are calling them pages, what we are talking about. So like I said, what the operating system will do when the RAM is like the space is not enough, what the operating system will do, it will get a page from the virtual memory, which is like the hard disk drive, and then shift it to the main memory. And on our right, we are seeing a process undergoing execution. Then virtual memory, we are saying this is designed to enable larger programs to run on the computer. Some programs are too large to be run on the computer, so it is virtual memory that enables these larger programs to run on the computer. And how does it do this? We are saying by allowing a program to use more memory than is physically available in the computer's RAM. When the program needs more memory than is available, the virtual memory temporarily transfers data from RAM to the hard disk to free up space. So we all know RAM is volatile. So when it is like the device is shut down, it can easily lose its data. So in virtual memory, how it will enable larger programs to run, it is through transferring the data which is on the RAM to the secondary memory, to the hard disk drive. So when this data is transferred to the hard disk drive, it frees up space in the RAM, and that is where these larger programs will then be executed. We have compaction. We are saying it's a memory management technique in which the free space of a running system is compacted, like put in one. Compacted is like to compress something. To reduce fragmentation problem, we remember fragmentation is dividing the memory space. So here compaction is to bring them together, and it is to reduce fragmentation problem and improve memory allocation efficiency. Then we have page replacement policy. Page replacement policy refers to a scenario in which a page from the main memory should be replaced by a page from the secondary memory. We looked at the diagram of paging above there. We saw how the pages can be in the main memory and in the virtual memory, the physical memory and in the virtual memory. So for page replacement memory, is a scenario in which the page from the main memory is replaced by a page from the secondary memory. And we are saying it occurs due to page faults. Then we also have algorithms that are used in page replacement. We have FIFO, first in, first out, optimal page replacement, and the rest of the page replacements policy. So coming to the algorithms, we have first in, first out. This is the simplest of the page replacement algorithms, and we are saying in this we maintain a queue of all the pages that are in the memory currently, and the oldest page in the memory is at the front end of the queue, and the most recent page is at the back end of the queue. So when a fault occurs, what the operating system will do, it will look at the front end of the queue to know the page to be replaced, and it will be replaced by the newly requested page, and it also adds this newly requested page to the rear end and removes the oldest from the front end. I hope you have gotten it right. Then you have optimal page replacement. This is the best algorithm that we can use, since it results to large page faults. And in this one, the pages that are replaced, they are replaced with the ones that are used in the longest duration of time in the future. We have least recently used page replacement policy. So in this one, it keeps track of how the pages are being used, and what it does, the page that will be replaced is the one which is least recently used. We are saying it works on the basis of the principle of locality of a reference, which states that a program has a tendency to access the set of memory locations repeatedly over a short period of time. So in this algorithm, like I said before, when a page fault occurs, the page that has been used for the longest duration of time is the one which is going to be replaced by the newly requested page. Then lastly, we have last in, first out. This works by the newest page being replaced by the requested page. And we're saying it is usually done through an attack, where we maintain a stack of pages currently in the memory and the newest page being at the top. So whenever a page fault occurs, what the page will do, the page at the top of the stack is the one which is going to be replaced. I hope you have gotten all these techniques that are used in memory management, and we have understood the whole topic of memory management. So for more information, for more reading, you can go on those references below and learn more about it. Thank you so much.